Okay, so number 34, we have to show that. So let's go from the right-hand side. So 1 over x minus 2 minus x over x squared plus 4. So we will multiply this by x minus 2 and this by x squared plus 4, top and bottom. And this is like plus a negative x. So top is x squared plus 4 minus x squared plus 2x over x squared plus 4, x minus 2, so that it equals, those will go away, so 2x plus 4 over x squared plus 4, x minus 2. So that's A, which is the left-hand side. Okay, hence, so that means you have to use that. What else would we do? 2x plus 4. Oh no, sorry. We want 1 over x minus 2 minus x over x squared plus 4 dx. Okay, so this one is fine. This one is not fine. But we can do substitution. You just get to a point where you have all these kind of tools that you can use. But some of them just don't work out. But substitution will work here. All right. So, just a second. So we want u to be x squared plus 4 and du dx to be 2x. So that dx is du over 2x. So we will have 1 over x minus 2 dx minus x over u and then du over 2x. So this is 1 over x minus 2, and then this, those will cancel. Have the 1/2 outside, 1 over u du. So the first thing is natural log x minus 2. Then minus 1/2 natural log u, which is x squared plus 4, plus c. All right, 35. We can divide this thing. So we're going to have e to the x over e to the x, which is 1, plus 1 over e to the x, which is e to the negative x, dx. So this is, the 1's going to be x, and this is going to be e to the negative x over the derivative versus chain rule, negative 1 plus c. So x minus e, well, we can write it 1 over e to the x plus c. Now this one is different because it's, you can't divide it. But we could use u to be e to the x plus 1, so that du is going to be e to the x. So dx is du over e to the x, which will cancel that. So our integral becomes e to the x over u, du over e to the x. So we're going to have 1 over u du, which is natural log u, which is e to the x plus 1, plus c. So the first thing I tried was making the denominator u, but that didn't work. So now let's try numerator. So that's e to the x, which means dx is du over e to the x. So our integral becomes, oh, I know. This actually, we're just going to leave that e to the x. And then this is going to be u squared plus 4. And then du over e to the x. So that these cancel. And this is going to become arctan. So this is going to be 1 over 2 arctan u, which is e to the x over a plus c. I think we'll try the same thing here. U is 3 to the x. So that du dx is natural log 3 times 3 to the x. So dx is du over natural log 3 times 3 to the x. So now we leave that 3 to the x. U squared is going to be 3 to the x squared, which is 3 to the 2x, right? Which is 3 squared to the x. Okay? So this is going to be u squared plus 9 down here. And then dx is du over natural log 3 times 3 to the x. So those cancel. Natural log 3 is just a number. So 1 over u squared plus 9 du. So that we have 1 over natural log 3. And then this is going to be times, this is arctan, 1 over 3 arctan u, which is 3 to the x, over 3 plus c. So this is going to be 1 over 3 natural log 3 arctan. This is 3 to the x minus 1 plus c. All right, this one. Great. Okay. So x is sine theta over 2. Dx d theta is 1/2 cosine theta. So we have to have this. Okay. So now we're going to have our integral is square root of 1 minus 4x squared . So 2x is sine theta, and sine theta squared is sine squared. And then dx is 1/2, which comes out cosine theta d theta. And we know 1 minus sine squared is cosine squared. Square root of cosine squared is cosine, and cosine times cosine is cosine squared theta. So now we use cosine 2 theta is 2 cosine squared theta minus 1. So cosine 2 theta plus 1 over 2 is cosine squared theta. So the 1/2 comes out first, so 1/4 integral cosine 2 theta plus 1 d theta. So this is 1/4. This is going to be sine 2 theta over 2 plus theta plus c. And distributing the 1/4, we're going to have, and also I'm going to write, so sine 2 theta is 2 sine theta cosine theta. So I'm going to cancel the 2's, and it's going to be 1/4 sine theta cosine theta plus 1/4 theta plus c. Now, we need, okay, so sine theta, what we started with up here, 2x is sine theta. Sine theta is opposite over hypotenuse. So let's solve for the adjacent. So we're going to have 2x squared, so 4x squared, plus y squared is hypotenuse squared. So y squared is 1 minus 4x squared, and we square root. So now, sine theta is 2x. Cosine theta is the adjacent over the hypotenuse, which is just 1, plus 1/4 theta. So if we have 2x is sine theta, theta is sine inverse or arc sine 2x. Then plus c. That's the final answer. Well, we can simplify this a bit more. So we have 1/2 x root 1 minus x squared, 4x squared, sorry. 4x squared plus 1/4 arc sine 2x plus c. All right, using appropriate substitution. So the only thing you can really do here is separate this into sine x and sine squared x. And then we need to get rid of one of these things. So if you do like this and you make u cosine, du is going to be negative sine, which means that dx is going to be du over negative sine. So our integral becomes sine x 1 minus u squared du over negative sine x, which cancels. So this is negative 1 minus u squared du, and that's going to be negative u minus u cubed over 3 plus c. So that's going to be negative cosine x plus cosine cubed x over 3 plus c. All right, 40. So du dx is going to be cosine x. So dx is going to be du over cosine. So this is going to be u cubed and then cosine cubed x du over cosine x. So this is u cubed cosine squared x du. So we need to turn that into 1 minus sine squared, and then that into 1 minus u squared. So that is u cubed minus u to the 5th du. So now that's going to be u to the 4th over 4 minus u to the 6th over 6 plus c. So u sine to the 4th minus sine to the 6th plus c. Okay, so this one, we need to integrate, but now there's not going to be a constant. So this is going to be an arctan. So it's going to be 1 over 2 arctan x over 2. And we want to evaluate that from 0 to 2. So we're going to substitute in the 2 and the 0 and subtract them in that order. So it's going to be 1/2 arctan 2 over 2, which is 1, minus 1/2 arctan 0 over 2, which is 0. So now we've got to think. So remember, arctan goes from negative pi over 2 to pi over 2. And we have, so when is when is tangent 1? And that's happening at pi over 4. So we've got 1/2 times pi over 4 here, because that's root 2 over 2, root 2 over 2. And then minus 1/2. When is tangent 0? So remember, tangent is just here. So when is tangent 0? So remember, that point is 1, 0, and that is at 0. Okay, so this is times 0. So this is just pi over 8. All right, so for this one, we integrate. This is arctan, so we're going to have 1 over 2 arctan x over 2, and we are evaluating that from 0 to k, and that's going to be equal to pi over 6. So we've got 1/2, and I'm actually going to factor out the 1/2. So that's going to be arctan k over 2 minus arctan 0. And that's equal to pi over 6. So if we multiply by 2, we're going to have this is equal to pi over 3. And we just did arctan 0, 0, so that goes away. So we just have arctan k over 2 is pi over 3. So if we do the tangent of pi over 3, so tangent pi over 3 is here, and on the fingers, pi over 3 is here, and that is 1/2 root 3 over 2, and the y over the x is root 3. So we're going to have that k is 2 root 3.